Continuing lesson 1.7 on the distributive property, if you look at page 47, problem 3, they're asking us what the simplified form of this is. So there's a negative out in front of the parentheses here. Probably the easiest way for us to look at this is that next to that negative we can put a 1. So we can say that's the same as negative 1 times the quantity 2y minus 3x. And at that point, like we've already talked about, you have a number next to a set of parentheses that they're adding or subtracting. You can use the distributive property. So distributive property will have negative 1 times 2y and then plus negative 1 times negative 3x. If it helps you to see it, since they're subtracting here, you can add the opposite. And once we multiply those, then we'll get negative 2y plus 3x. So again, basically, if there's a negative next to the parentheses there, you can put a 1 there, and then you'll be able to distribute that. So if we look at the got it, part B, doing this one just because it's a little bit different than the one in the book, so a little bit of variety here. So once again, we can put a 1 out in front here, and then at this point we can distribute. If it helps you, if you want to, there's not a number next to the x. If you want to put a 1 there, you can. And so then we'll be doing like negative 1 times negative 1x plus negative 1 times 31. So the first part here, if we're multiplying negative times negative, is a positive, so that's a positive 1x. If you want to just put x there, you can. And then plus negative times positive is a negative, so negative 31. And you could write that a few different ways. So you could put 1x minus 31 or x minus 31. All three of these answers would be equivalent to each other. So we're going to look at problem 4. Just talks about how sometimes using distributive property can make things easier if we're trying to think things out in our head or stuff like that, or even just working it out if we don't have a calculator. So problem 4, deli sandwiches cost $4.95 each. What's the total cost for 8 sandwiches? Use mental math. Even if they tell you use mental math, I still want you to write stuff down to show your work in case you miss it. We can figure out what went wrong. Okay, always show work. So 8 sandwiches, $4.95 each. So we could do 8 times $4.95. What the book's pointing out is that $4.95 is pretty close to $5. So what we could do is we could kind of do an equivalent expression here. Instead of $4.95, we could say that's like $5 minus 5 cents. And then at that point, we would be able to distribute. So we could do 8 times 5 minus 8 times 5 cents. So 8 times 5 is 40. 8 times 5 cents is 40 cents. Maybe we put a 0 there since it's money we're talking about. And then $40 minus 40 cents is $39.60. Okay, so again, just a way that potentially if we were trying to think this in our head that we could do that a little bit quicker maybe. So the got it, number 4. Julia commutes to work on the train 4 times each week. A round trip ticket costs $7.25. What is her weekly cost for her tickets? Okay, and so we're going to make an assumption here, I guess, is that, oh, actually, it already tells us here, 4 times each week. Okay, I was going to say we're going to assume that she's not working every day, but it actually gives us that information. So it's $7.25 each time, 4 times a week. So normally we would just do $7.25 times 4. If it doesn't say you have to use distributive property, if you want to just do it that way, you can. What they're wanting you to do with this being distributive property is if we switch that around this way, and then what we can do is split that up. So $7.25. So that's close to $7. Not estimating, but what we could do is break this up as $7 plus 25 cents. And then we could distribute that. So 4 times 7 is 28. 4 quarters would be $1, and that would be $29. Another option somebody mentioned is that the 25 cents, 0.25 is the same as 1/4, and 4 times 1/4 is 1. So either way you want to do that, you should get $1 for that part, $29 overall. So on the next part here, we've got a little bit of vocabulary we're going to talk about. First of all, is a term. So a term, we could say it's a number, a variable, or the product of a number and one or more variables. And when we're naming our terms, I'm going to say terms are separated by addition signs. Makes it easier for you guys to come up with the correct answer for what the actual terms are. We'll talk about that more in a minute. So if you're subtracting, then we're going to add the opposite to figure out what our terms are. And again, we'll get into that a little bit more in a minute here. So some examples of terms: we could have 5, we could have x, we could have -3/8 xy. Those are all examples of terms. It's all stuff that's multiplied together. If there's more than one thing there, notice there's no addition or subtraction on those terms. The next thing is constant. A constant has no variable. So examples of constants are 7, -1/4, 4/10. So if something's constant, it doesn't change. So if we just have a plain number, there's no variable. Just a plain number is constant. And then our next definition is coefficient. Coefficient is a number that a variable is being multiplied by. So, I guess as an example, if we had -3x, -3 is our coefficient here. It's just the number the variable is being multiplied by. And I mean, for coefficient, we're not normally going to have to do anything with that. It's just kind of a vocab deal where, you know, if they said, what is the coefficient of this term, you'd have to understand what that means. Like terms, we talked about before. Like terms, the variable part is identical. And the reason like terms are important is because like terms can be combined. So if we have an expression or an equation, we can combine like terms. So some examples: 8x and -3x. Those both have just an x on them. 2 and 1/7. Those are like terms. They're both constants. We know we can add just numbers together. 5x cubed and 2x cubed also are like terms because they both have x cubes. And that's the thing, is that variable part, it can't just be the same letter. If it has exponents, exponents have to be the same also. So, I mean, we can't just have like 8x and 2x cubed. Those are not like terms because there's different exponents on the variable. Okay, if something's being cubed and multiplied by another number, and then something's just the plain number times something, we can't just combine that all together. So the bottom of page 48, it kind of goes through all this stuff that we just mentioned, and they kind of mention some things we already talked about. So you can see here in blue they've highlighted some coefficients, in red they highlighted a constant there, and they've also highlighted what the terms are here. Now when they say those are terms, here was the starting point. So if that's the starting point and it says what are the terms, like I mentioned, this is where you guys would go ahead and add the opposite, and then now you can say these are my terms. Okay, if you don't add the opposite, you've got to think of that negative as being with that term. So it's probably just easier to add the opposite and then just say our terms are then separated by the addition signs. So at the bottom of the page, very bottom, it talks about some different examples here about like terms, or terms, variables, and whether these are like terms or not. So 7a and negative 3a, the variable factors, the variables are both a, and so these are like terms. 4x squared, 12x squared, the variable parts are both x squared, so these are like terms. 6ab, negative 2a, we have an ab and we have an a. Those are not exactly the same, so those are not like terms. And again, the significance there is that if they're like terms, we'll be able to combine them together. We'll be able to add them or subtract them. So an algebraic expression is in simplest form if it has no like terms or parentheses. No like terms or parentheses if it's in simplest form. So if they ask you to simplify something, it shouldn't have any like terms in it still. It shouldn't have any parentheses still in it. So there's an example, not simplified versus simplified. So problem 5, they talk about combining like terms. So 8x squared and 2x squared, if we're adding those are like terms. The variable part's the same. We can add those, would be 10x squared. Part B, my suggestion right off the bat on part B, anytime they're subtracting, is to go ahead and add the opposite. You don't have to do that, but a lot of people find that helpful. And then we're just going to go through and look for like terms. You can rearrange things. Commutative property can rearrange at that point since they're adding. If you don't want to actually physically rearrange them, I'm okay with that. You can just hunt for the like terms, so you can say 5x and negative 3x would be 2x, and then we've got a 6y here, that's my only y term, and then we've got negative 3 and a 4. Negative 3 plus 4 would be a positive 1. So that would be simplified. There's no like terms left, and there's no parentheses left at that point. So if we look at the got it, they're asking what the simplified form is for these expressions. So we're going to go ahead and look at these A, B, and C. And then I've got a couple other problems we're going to talk about after that. So on part A, probably what we want to do here is go ahead and put a 1 in front of the y there. And then we could just say 3y minus 1y is 2y. Kind of like 3 minus 1 is 2, only we just add that y in behind it. 3 times something minus 1 times something is the same as 2 times something. Okay, if you want to add the opposite there, you can. That one is not a big deal. Like I said, mainly reasoning for adding the opposite. More so if you're going to get a negative answer, or if it asks you what the terms are in an expression. Part B. This would be a case where I might suggest that you add the opposite here. Again, it's not a requirement, but I've just seen some people have more success by doing it that way. So then when you add these together, this would be negative 12m to the fourth power. Those variable parts, there's a lot of variable stuff there. Since it's identical, these are like terms, and we can combine those together. Part C. So if you want to add the opposite here, you can. Be careful with this. These are not actually all like terms. We have a y cubed z. This last one also is y cubed z. We can put a 1 in front of that. 7 plus 1 is 8. So 8y cubed z plus negative 6yz cubed. Or if you didn't add the opposite, that's fine. We didn't have a like term with it anyway, so whichever way you want to write that. But again, they're not all like terms, so don't combine those all together. Okay, a couple other problems that were not in your book I want to look at here. So first of all, 5x squared plus 7x squared. Those are like terms. We'll just add those. Would be 12x squared. And a little bit more interestingly, we have this one. So 7x minus 5 minus 3x plus 2y plus 1. So one thing to start out with here on the subtraction parts, if you want to go ahead and add the opposites there. At this point, we're going to try to find some like terms, combine those together. When you do these problems, usually the way they write answers is starting with variables alphabetically. So whatever's first in the alphabet usually comes first on down the line, and then the constants are usually at the end. If you don't have them in that order, it's not wrong. It's just that's how they're going to write your answers. So it'll make it easier for you if you're checking your answers if you write them that way. So I'm going to start with the x's because that's the first thing alphabetically here. 7x and negative 3x would be 4x. Then I've got another letter, which is y. And there's only one y term, so I'll just bring that down, plus 2y. And then we have two constants here. So we've got a negative 5 and a positive 1. Negative 5 plus 1 is negative 4. So you can say plus negative 4. In the book, they're probably just going to put it as minus 4. And those are the same either way. And at that point, there's no like terms left, no parentheses, so we're in good shape. So on the lesson check, let's look at a few problems here, starting with part B. The question is, what is the simplified form of the expression? Use the distributive property. One thing on this problem, since there's a negative out in front and they're also subtracting inside the parentheses, if you want to add the opposite here, you can. You don't have to do it that way, but just something to think about. And then we're going to distribute. So we distribute, we got negative 8 times x plus negative 8 times negative 3. And then that would be negative 8x plus negative 8 times negative 3. Negative times negative would be a positive 24. Those are not like terms, so we are done at that point. Go down to number 4, and they're wanting us to tell whether these are like terms. So we can just say yes or no if you want. So number 4, we've got 3a and negative 5a. And those are like terms, so yes, they both just have the a's on them. Number 5, we've got 2xy squared and negative x squared y. So on this one, be careful. But we got xy squared, we got x squared y. Exponents are on different variables there, so those are not like terms. If we look at number 7, how can you express 499 to find the product 499 times 5 using mental math? And they are asking us to do that, so we can't just work it out by hand, 499 times 5 like we might normally do. Usually what I like to do on these problems is think about which number I'm going to break apart. And I'm going to put that number second because it's going to be like what I'm used to seeing when I distribute. So by breaking apart, it's either going to be something plus something or something minus something, just depending which I need to do to get to that number. So since 499 is really close to 500, we can say 500 minus 1, and then we could distribute that. Again, even though it says mental math, I want you to show what you're doing here. So we multiply these, 2,500 minus 5, which is 2,495. All right, and then if we look at number 8, they're asking if these are in simplified form. They're not asking us to simplify them, they're just asking if they are in simplified form. So part A actually is yes, because these variable parts are different than each other. They're not like terms, so we can't combine those. Part B would be no. We would be able to distribute here. There's parentheses still, so it's not simplified. So we would distribute that and get our answer. So part C, we got to be careful about on this one. Just looking at it, we got an x squared, xy, yx. They're not the same. Actually, in fact, though, since the stuff's being multiplied together, we can rearrange. If I multiply 3 numbers, if I change the order I'm multiplying, I'll still get the same answer. So that actually is the same as minus 3xy. And at that point, those are both xy terms, so we could say that that is not simplified. We'd simplify, we get 5x squared plus 9xy. So this gives you an idea of how to use the distributive property and simplifying.